I'm Niall. I'm a data engineer at Tails.com. Here I am picking some pumpkins on Saturday ahead of Halloween. And before joining Tails, I graduated from Imperial College London in electrical engineering before moving over to data. So, introduction to data at Tails. We were fairly early adopters of DBT at the start of 2018. We started on Redshift and we're now running on Snowflake. Our deployment is an in-house implementation backed by AWS, and our model build time is going up and sits at around 70 minutes at the minute. We have a monolithic deployment, which people are throwing around more and more, but that basically means we deploy all our models at once at the end of each build. There are 10 regular committers to the project, and we've got a rough breakdown of the roles on the right there. And like all data teams, the requirements of our data modeling keeps increasing. So some of the requirements require faster update frequencies, and we need to ensure that bad data in one part of our DAG doesn't prevent other independent models from being deployed. This has led to a decision to create individually deployable subsections of our project. And to deliver this work in an effective way, we needed a robust, dependable, and fast development experience. So I'm going to share with you how we moved further in that direction. Just before we go any further, I thought it'd be really helpful just to recap what CI is. So it's a term from software engineering, and even as an engineer, I thought it was still an interesting exercise to go and look up the formal definition. So thanks to Wikipedia, here we have a textbook definition, but the broad aim is that you continually merge several collaborators' code, which is increasingly important with more and more frequent contributions. I mean, it helps you locate errors quickly and ensure kind of continual compatibility rather than, everyone merging their code once a week to find that it doesn't work together. By doing it all the time, you encourage a kind of frequent discussion and review, which is really important. So if we don't have quality testing in place, then it won't be until production until we discover the errors. One way to combat this is to borrow a design pattern from software engineering called blue-green deployments, which Alan spoke about earlier this year. We already have that in place. And while this ensured that the data would keep flowing in the case of an error in production, it did mean that our deployments frequently stalled if poor code was merged into production. This could take quite a while to fix, and it blocked other contributions from being made in the first place. So we needed a CI process which was fast enough not to kind of hinder the speed of iteration, but also thorough enough to detect issues before they made it through to deployment. So some kind of typical steps from creating a pull request from kind of fundamentals. Automated testing should be really comprehensive, and it should be as fast as possible to reduce the iteration time. And in step 2, the outcome of the tests that we're running should be really specific and actionable. We want to be able to view the output as well of the models really, really easily so that we can go and locate any issues if they're more complex than just a kind of naming error or problem like that. And then when it's time to request a review, it's really important that our review time is spent with quality conversation discussing methodology rather than bad formatting or inconsistencies in our best practices. So following these steps, I've narrowed down what I think are the kind of 3 biggest goals that we wanted to work toward to improve this experience for our developers. So here they are. So number 1 is fast and efficient CI, and that's the headline of the talk. So I'll be talking about that first. And then secondly, we really wanted to achieve direct and actionable feedback with some persistent build results, which you can view beyond the build process. And then thirdly, consistent formatting conventions. So there are a few ways that we solved that as well, which we'll talk about at the end. And then this all kind of combines together to hopefully result in an enjoyable development process where the CI doesn't feel like it's blocking you from getting your work out quickly, but it helps you catch your errors quickly and kind of agree on a process and improve consistency. So firstly, fast and efficient CI. How can we achieve comprehensive but also fast testing? And the solution today that I'm going to focus on is minimizing what we build. So the problem was solved at ClearCover earlier in the year using the GitHub API to retrieve the name of the changed files in a pull request in the diff. and it works really well for them. And I definitely recommend checking out their presentation for ideas for kind of staged deployments. But the really cool thing is, this is now supported natively in DBT. So in May, the issue was first raised with some kind of suggestions on how this could be solved with this, what they've coined the term slim CI. And then further into the year, in September, the state modified and state new selectors were added in DBT 0.18, which is really, really exciting to see. So how does this work? Well, when DBT compiles your models, when you run a DBT compile or a DBT run step, you generate this target folder, which we've all accidentally committed at some point. But in that folder, amongst other things, is a manifest file. I really wouldn't recommend opening it, but if you do, you can see that DBT generates a hash for each model in your project. And a hash is a unique identifier for that exact file. So if you change anything in that model, the hash changes. And by comparing two manifest files, so one from production and one from your pull request, DBT is able to identify which models are the same, which have been modified, and which are completely new. So using that information, how can we give DBT both our new manifest file and also the old one being the tricky bit? And this part, unfortunately, completely depends on your deployment. It's not a really simple answer. If you have your own deployment, the answer is likely that you'd upload the target folder or just the manifest file at the end of your run, which you can then retrieve during CI, which is exactly what we do. We just upload to an S3 bucket and retrieve it at the start of the CI process. If you're using DBT Cloud, I'm not sure how you do it, but hopefully someone from Fishtown can answer. Claire, feel free to chime in either now or at the end.
Yeah, I think maybe my coworker Jeremy's going to chime in at the end with how to do it in DBT Cloud.
Okay, wicked. Well, make sure you hang around until then. But before I go on to show you the kind of final set of commands that we use once we've got the manifest file, I want to explain a bit about what each of these state CLI commands actually do. So copy and pasted from the DBT docs. There's a link at the bottom. Go and have a read there if you want to read more comprehensively. But state new will only run models which didn't exist in the previous manifest file. State modified, however, runs all the new models and any modified models. So in our case, we want to build as little as we can, but also comprehensively. So we need the state modified selector plus the downstream dependencies. And yeah, have a read of the full docs to kind of read exactly what's going on. But we need state modified with a plus at the end for everything downstream. So having said that, here are the DBT commands. So it's actually quite straightforward. Step one, we're building all of the new or modified seeds, which looks a little bit differently to how we run models. We use this kind of select syntax. And where we've got state and then what says prod target dir in our code here, that's a pointer, or well, the directory in which we have our production manifest files saved. And we need that so that DBT can do the comparison between the two files. So we do the seed, then we do the run with the modified and downstream models. And then finally, we test, again, all of our modified and downstream models. So that is efficient CI running the bare minimum while ensuring comprehensive testing, which can minimize our build time and maximize our iteration cycles. So that's step one, goal one rather. Goal two, we want to achieve direct and actionable feedback with persistent build results. So how can we achieve the same direct feedback in CI that we achieve through CLI commands, where we do DBT run and then get a list of errors? Well, hopefully not errors, but if we do, they're right in front of us and we can action them directly. So previously, we're all used to this world where you create a PR and you wait for your build to pass or fail, and then you get this little cross, and then you have to click details, and then you have to click the run step, scroll through the logs, find the reason your build has failed. There's no need to do that. So I thought, how can we automate this process? Let's add a comment. So our build step now at the end of a run puts a comment on the pull request, which is automatically emailed to you as well, because it's just a normal GitHub comment. And it provides a link to the exact commit diff at the top of the comment so that you can really easily see exactly what commit has been run and relate it to the failure if there is one. We've got the failure from the dbt run command. That's just been passed from the logs. And then at the bottom, there's a link to, well, not a link, but the name of the database, which you can go and view the built tables at. So here it is in full screen. Back to the PR comment. We've got this reference at the bottom. And so now I'd like to kind of talk about the decision behind where we're building the tables, how we're doing it. And so we're using Snowflake, which has this feature called zero copy cloning. And we're able to cheaply produce a replica of the production database. We replicate the database per commit, and then once the PR has been merged, we just delete it. So we have a script that runs every night and cleans up all of the databases so that we don't end up with a horrendous looking warehouse over time. The advantage of doing it this way is that we have a database every single commit, so we can really easily compare the output of different commits. We can see how long a different views takes to query, how many rows there are, if there are any issues like that. And our production database is about 60 gigabytes in size, and the zero copy clone means that it's actually really cheap to do this. So the source underlying data remains the same. It's just two databases viewing the same data. And if those models are updated, then Snowflake produces a new copy. And for reference, Snowflake charges around $40-ish a month per terabyte of stored data. So doing this is just, it's a bit of a no-brainer really. It doesn't really cost anything, and it's really helpful to do. So goal number 3, consistent formatting and conventions in our project. It's a contentious area, but getting it right is really important so that we can spend time discussing interesting things, not formatting issues. So there are a few ways of doing this. The way we've done it is we've got a set of kind of internally agreed best practices, naming conventions on models. We use the dbt coding conventions as well, which are a really, really good place to look for some good starting points. And we're also using SQL Fluff, which soon we'll be able to apply the full set of dbt coding conventions automatically. So quick screen grab and plug for SQL Fluff. This is the kind of stuff, this is a subset of the rules that SQL Fluff can enforce. It's come a long way in the last year, and it deserves a whole talk of itself, but thankfully it does coalesce in a few weeks. So look out for Alan's talk nearer the time and come along. Thanks for that, Ken. No leading commas. Bring it all together. Here are our final CI steps. So number 1, we apply SQL Fluff linting. It's got to be the first thing. It's got to look good and be easy to read and easy to review. Secondly, we go and get the latest manifest.json from production in cloud storage. We then do the zero copy clone into a CI database just for the commit. And then using that database, we run our modified and downstream models against it. And then depending on the output, we either comment with success or unfortunately your build has failed. Here are the reasons why. So the next question is how fast is it all? So the clone takes about 4.5 minutes to run. It's a zero copy clone. I don't know Snowflake's internal workings completely. I thought it would be faster. That's maybe one to look into or speak to the Snowflake people about at some point. But the bulk of the time is taken up by running the models, which obviously depends on where your model is. If it's right at the edge of the DAG, it will just need to run that model because it has no downstream dependencies. If you're changing a staging model, you're still going to have to build most likely the majority of the DAG, which will take time. But importantly, it's as fast as we can possibly go while still retaining comprehensive test coverage. So it's a lot faster than just a blanket dbt run. Let's wait an hour and see what happens. It's a lot faster. So back to our goals. Fast and efficient CI. So yeah, as I've said, we're now building far fewer models and we're still retaining the same quality and comprehensive test coverage. We've got some direct and kind of actionable feedback and persistent build results. So if there's a failure, you can dig into the detail, find out exactly what's gone on. And we've got consistent formatting and conventions, some of which are just written down in documentation and some of which are applied programmatically with SQL Fluff as part of the CI steps. In terms of an enjoyable review process, I think time will tell as we enter this new piece of work that we need to do. But this process, building a CI process is a kind of continuous work, and actually asking people what they think of it, how we can make it better is something we'll keep doing. Some of our analysts and users are on the call, and I'm sure we'll be happy to answer any questions about the experience. But some improvements from here that I'd still love to add are a way of commenting some kind of feedback on the model complexity. So if someone creates a pull request and they add some logic to a model, it would be really cool to get a diff in time between the previous model and the new one, so that we can identify maybe kind of inefficient logic before it's merged into production and we find our build times go up by 10 minutes. So I'd love to do that. I'm not sure how, but I'd love to do that. Another thing I'd like to do is a snapshot of the DAG for the models that have been changed. It'd be really cool to visualize how the dependencies run between changed models, which can maybe inform, whether the references are correct or whether there's something we can kind of streamline in the DAG. And then finally, finish implementing the DBT coding conventions in SQL Fluff, which should be happening in the next couple of months, hopefully. So some final thoughts before questions, just to think about from today is, how can you make contributing enjoyable? The speed definitely helps, but having the quality conversation is a really important one. Not trying to understand, differences in formatting, but talking about the methodology of the change. Thorough test coverage. It's really important that we don't make failures enter production, catch them early. That's what CI is all about. And finally, try SQL Fluff, have a play, raise any issues that you have. So thanks very much. Happy to answer as many questions as we have time for. Over to you, Claire, I guess.
Yeah. Oh, wow. Thank you so much. That was really impressive. I think, Fatima, can you quickly invite Jeremy on stage, and he's going to maybe show us how to do that, the sort of the state modified runs in DBT Cloud. So we'll just get that sort of set up in the background. But in the meantime, one other thing that I was thinking about CI processes, like the one thing that I've done really quickly is implementing a pull request template, like the easiest win that you can possibly have. And it makes such a huge difference on the quality of pull requests and making that sort of path to getting your work merged a lot easier, I think, when you have nice, helpful comments about like what text you should be adding to this pull request. So that's my extra tip to add to improving your CI flow as well, which I'm sure the Tails team do.
Cool. Yeah, no, Ken added that a couple of weeks ago, actually.
Yeah. It's like so incredible.
It's a difficult one between, you don't want to avoid being overly prescriptive, because then we just find that people control it and backspace and then just put whatever they want in. So kind of finding a balance between a layout which helps people describe their pull request and being overly bureaucratic that's really important. Yeah,
I'm most famous for implementing pull request templates and then never sticking to them myself.
Exactly.
But it's good to have the options there.
Yeah.
Cool. I'm not sure if we're getting Jeremy. Maybe Jeremy, if you want to. There we go. Oh yeah, sorry, I should have said this. In the meantime, if anyone has any extra questions, feel free to use that ask a question button. I think it should be in sort of the middle to the right of your screen, and then we'll start going through those once we've heard from Jeremy. Niall, I might get you to quickly stop sharing your screen. Just I think Jeremy's having some permissions, giving access to Crowdcast to access his video, things like that. While we're waiting for that, another question for you. When do you think is a good time for teams to go, okay, this is a thing we need to invest in? Because like if you're a really small team, taking a step back and investing in CI processes can feel difficult to prioritize when you've got stakeholders knocking down your door for reports that are broken and things like that. So was there a point where your team went, okay, this is really painful for us and we need to prioritize this, or has it sort of always been a priority?
Yeah, well, I guess the implementation is always, it's a kind of one-off cost with, maybe continuous modifications, but it really pays itself back quite quickly over time. If you think of the cost of an error going into production from the time it takes to solve, and depending on your deployment, the result of kind of stale data, that is so high that I think that having comprehensive testing everyone should have that, like as a minimum. It needs to be there. In terms of the more complicated stuff around, shortcutting, going to your CI tool, I think that depends on how many contributors you have, the frequency of the commits as well. It feels like quite a small improvement, but when you have 10 pull requests a week, it all adds up. So it's about making that kind of cool. But as a minimum, I think every pipeline should have testing. Yeah.
Absolutely agree with that. Interestingly, only like 60% of projects have tests. I don't know if that number's still true. Jeremy might be able to say, yeah. So 60% of projects run the dbt test command. So for 40% of people, probably not 40% of people on this call who are biased, but for 40% of our users, that's an easy win there for them. Jeremy, I want to say welcome to the show, but it's not really.
No, thank you. I feel like, have you seen the film A Star is Born? And familiar where Bradley Cooper invites up. I feel like Lady Gaga right now. I've been invited up. Tell me something, boy.
Oh man.
The resemblance is astounding, in fact.
Yeah.
Jeremy, do you mind quickly introducing yourself for those who?
Absolutely. Who would maybe be like, who is this person? What are these jokes? My name's Jeremy. I'm an associate product manager at Fishtown. I had the pleasure of working a lot on the 018 release, including specifically these like state modified, state new selectors, and this whole new feature set that's available in dbt. For the very first time, you can use the artifacts of yesterday to power the runs of today. Is that enough of an introduction? Did I overhype it?
Yeah. So Niall showed earlier how Tails sort of use these state modified selectors, and they rely on you having a previous version of the manifest.json or the different artifacts dbt runs produce, and they were able to do that. I think you're scheduling via Airflow. Is that correct, Niall?
We're actually scheduling through AWS CloudWatch event scheduler, which is a bit of a beast, but it works. So
okay, so there's a way to do this sort of no matter which deployment tool you're using, and it's just like how complex is it. So I've invited Jeremy up to show how we've done the same thing in our project. So Jeremy, do you have the ability to share screens?
Yes.
Or do you need me
to share mine?
Okay.
Give me just one more moment while I figure it out, and then yes.
We'll get there, folks. I can also open up our
share. No, that's the wrong kind of share. Oh yes, I found it. Okay.
Yeah, I was thinking for a second. Oh, I didn't have to share my screen today.
Okay. Are folks seeing dbt Cloud right now?
Mm-hmm.
Okay.
Yeah. Do you mind maybe zooming in a little, or dragging it to be more?
Yeah. So
landscape?
This is. I didn't tell Sophie in advance that I'd be sharing this, but hopefully that's okay.
Mm-hmm.
This is a pull request that made a couple of changes to a CSV file and also made a change to one model in our project. So obviously in an earlier time and place, we would need to rerun all of our models and all of our tests in order to just find out that like a few additional lines to a CSV file, to a seed, and a few additional lines in a model didn't break our entire project or break any of our tests. We've got the kind of standard, if you're familiar with dbt Cloud, if you've used it before, kicked off run as a result of the webhook from having opened this pull request. So again, everything standard, everything as before. The real difference is now we're able to execute this run in deferred mode, so to speak. And so we've got a little snippet that says, hey, this run execute in deferred mode using a manifest from the job incremental, from the environment production, the specific run deferred to, the specific production job whose manifest we snapped up for comparison. Got a link there, and we could open that up on the side. And then if we go down the list of steps here, we do a zero copy clone here because we're also on Snowflake. This isn't strictly necessary. I'll say a little bit more about that in a second. So what we've got is a seed step that only seeds the new or changed seeds. So in this case, the one that we added a couple of rows to. Model run, so just that seed and that model and any of its dependencies. And then we actually have another run step just in the event that we have incremental models. So this is the intersection of modified incremental in the case that we made a change to that incremental model, which wouldn't cause a failure in the full refresh step, but would cause a failure. If I had mistyped my is incremental logic, for instance, done the classic thing of I had a where condition and then I wrote another where condition right below it. We've all been there, I assume.
I certainly have, yeah.
So maybe the question here is, how does dbt cloud know to whom to defer and when? In this case, it's just part of the job definition.
Cool.
So right under webhooks, same place I put run on pull requests, I'm able to say, do I want to defer to another job, to a previous run state? And I can pick the job from the same project.
Cool. So do you need to specify the state directory in your run commands, or is that added on through the side somehow?
It's actually added on through environment variables.
Ah, okay.
Yeah. So one thing that's in the docs, and you can certainly read about it, maybe this is convenient for your deployment. If you're deploying in Airflow, maybe you're perfectly happy passing it with the state flags, but you can specify defer and state with command line flags. You can also just set them as environment variables.
Cool. Nice. Okay.
Yeah. So in this case, dbt cloud has set those environment variables. That's a little too zoomed in, saying where this is where I wanted to be, saying where those artifacts are going to be. Yeah. And I don't have to worry about like finding the file, putting the file somewhere, making sure the file is still there, any of it.
Making sure your AWS creds work for the file.
Making sure my AWS creds, yeah.
IAM roles are a thing that are an unknown beast to me.
Yeah.
One day I'll figure it out.
But this is another place where the core functionality is identical. It is exactly the same. It's just a matter of convenience here, where dbt cloud is already in the business of persisting all of your run artifacts. It knows where they are. It can find the one that you want. The way this works is it always picks the most recent successful run of that comparison job, and then pulls the manifest from there. By the way, if you are during this call logging into your own dbt cloud account and confused as to why you don't have the option for that defer to a previous run state, it's a feature flag right now. It's a beta feature, so you can reach out to either someone from support or I think a thread that I have in the dbt cloud channel in dbt Slack, and just give your account number. We'll make sure you get access.
Cool.
I did say I was going to say just a little bit more about the zero copy cloning earlier. The reason this isn't strictly necessary is because of that defer feature, which I think Tails may not be using, but we certainly use. These models actually push their references up to the production schema. So they defer their references, even though we are right now building models into dbt cloud PR 1862.231. They're actually selecting from the analytics tables, the production.
Okay. So you actually operate with one database, and then you do kind of schema deploys.
Yeah.
That's right. We've got schema deploys. We do like that raw analytic separation. We could do different databases as well. But the important thing here being, we actually wouldn't have needed to clone stage snowplow web events into this schema. Instead, dbt is just kind of intelligently saying, hey, I know you're not running this model right now, but you need to select from it. Let's just use the namespace of this model that exists in the comparison manifest, in the other manifest.
Cool. Okay. And this would obviously also work cross database as well, right? It doesn't.
Totally.
Yeah. What happens in something that's downstream of that, though? Will it defer to the thing that you just built, or will it defer to the?
Yeah. So because this model, int cloud of account events current, is in the selection criteria for the run.
Yeah.
There is not deferral for this model. This model we will be building off of the version we're creating right here. Yeah. So it's just
until I didn't read all the release notes.
No, hey, it's just this is probably the trickiest piece. Like state modified, we kind of get. There's a lot of a lot of caveats, and you should read about it in the documentation.
Yeah, macros, maybe throw it off. And,
of course.
Yeah.
But you kind of get intuitively what's going on here.
Yeah.
Oh, like the file's changed. We figured out it's changed. This is a little trickier, but this is what lets you say, I only want to run the model that has changed. I don't want to have to build all of its parents upstream, especially if I'm on a database that doesn't have zero copy cloning.
Which, unfortunately, not every only one database has.
So blessed.
Yeah.
The reason we still have a zero copy clone step here is, frankly, for convenience of like BI. It's like we can then go into Looker from here and still run queries that depend on models we have modified and we've run, and some models we haven't modified and run, and not get a like, hey, your CI schema didn't build this unmodified model for me, but I'm expecting it in the dashboard, that kind of thing.
Cool.
Thank you.
Okay, Jeremy, thank you so much for joining us. I think we will say farewell to you from the stage now. There we go, magic. We had a question from Dan Hunt, a fellow Australian, but also living in London. Well, not also to me, but living in London. So like Niall is. So Dan had a question around, I've clicked onto the wrong thing. Does your team have a local workflow for running only the modified models on the currently checked out Git branch against master? So sort of same idea of like, you know, on your CI runs, you only want to build the change models. How do you replicate that doing a local run, if at all?
So simply no, we don't. In terms of why, I suppose the reason for me would just be that it's a step that we can automate. You know, you can just push your commit to the branch, the pull request, and all of this will run automatically. And also, there's a huge advantage in not running such, you know, long queries from your own machine. Laptops sleep, Wi-Fi, you know, goes all rubbish. So having that running on someone else's machine means that you can just go and do whatever you want. You can maybe work on some other work, and then you'll just get an email notification when it's complete. So that's why we haven't done it. But having said that, if you wanted to, each run overwrites the manifest. I'm struggling to understand what you mean by that. Do you mean the production manifest or your local one?
Yeah, I think because it will overwrite you couldn't use the modified selectors locally because that manifest.json, you've only got one copy of it locally, I guess.
Yeah, well, you could use it, but you just have to download it in the same way that you would do in CI. So yeah, every time you run any dbt compile or run, that target folder just gets overwritten.
Yeah.
So you'd need to have some kind of path manipulation copies to retain that old manifest, put it somewhere else so that you can then refer to it in the state selector. So hope that answers the question.
Yeah, cool. I largely agree. I think when I'm working locally, I have in my head the things that I've changed. And so as long as I know the models that I've been directly working on have SQL that works, I'm pretty happy to push it to the CI pipeline to figure out if I broke anything else rather than doing too much locally.
Yeah, well, the other
too early and then get a lot of failing CI builds. So at least we know it works.
Yeah.
Cool. We've got a question from Emily Hawkins at Drizzly up in Boston. So she says, in our project, we have many incremental models for different event data that would need a full refresh with any change, but we wouldn't want to run all history during testing. So yeah, do you have, I guess, a different approach when you're thinking about incremental models where the columns have changed, but you don't want to reprocess all the data because that would end up being a really long CI run? Yeah, any ideas there? I also saw that Tegan chimed in with some extra comments here. So.
Yeah, no, we've not solved that problem yet. I mean, this implementation in CI is relatively fresh. I'm sure we'll encounter more issues along the way, probably including this one. But for now, I've not had any kind of big issues with super slow runs.
Yeah, I think like the same thing for ourselves. We've like the easiest implementation of it gets it right 90% of the time, and then every so often there's like some.
You've always got to kind of work around edge cases.
Yeah. You just have to sort of figure out the easiest how to override a CI run. Like if you do need to just do a full run for that pull request.
Yeah, well, and an example where this has been tripped up actually is where tests which compare historical calculations against a kind of set of values that we know to be correct. So like aggregated revenue, right, per month. So we do a test at the end of each one, which basically says, do these still look the same? And one place where that actually tripped us up about a month ago is where in production, one of the databases from like a couple of years ago, one of our like the kind of core transactional databases had some problems in it. It had some errors, and they were historically fixed, which then resulted in a test failing, not because our models had changed, but because the historical data no longer matched our kind of comparison data. And that actually meant it was really hard to get it through CI because we'd change our comparison data, but it wouldn't rerun all the models up to that point because it was only running the downstream ones. So there are occasions where this doesn't work, and you do just need to force a full refresh. So coming up with a solution to that is probably a good idea as well. Just a button that goes, no, just run everything.
Yeah. Cool. Any other questions that we have left? I think this last question's more for Jeremy, so I might get Jeremy to follow up with Tegan because it's about DBT Cloud things. So Jeremy, reply to Tegan on DBT Slack there. Cool. We still have some more time if anyone has any more questions or wants to chat about any part of the Tails pipeline in detail. We're going to try out SQL Fluff on our own project very soon. So we're really excited for that. Yeah, we've got a new head of data, and we're nudging her, I'm not sure if she's on the call or not, nudging her to try and open source our internal project as a resource for the community. Sometimes it's do as we say and not as we do, and our SQL style isn't always perfect. So I'm really looking forward to using SQL Fluff to try and have a computer pick up those errors rather than having us manually.
Yeah, absolutely. Automate what you can. Absolutely.
Yeah.
Yeah, definitely. So check it out if you're not already using it. And it's still new. You'll probably run into errors. We still have a few models where we've had to kind of SQL Fluff ignore them because the parsing breaks around some ginger, but we're getting there. Yeah, we're really getting there. So give it a go.
Yeah. I'm not sure if Alan's on the call, but thank you is it mainly Alan that works on it?
So Alan's the core author. He did the kind of release, but there are now 5 or 6 maintainers who are kind of contributing more and more regularly. And there's an organization now, so it's an official open source project.
Ooh, wow.
Alan/SQL Fluff.
There we go.
So go and check it out.
Excellent. Cool. Well, I think we're just going to give everyone an early mark in that case if we don't have a ton more questions. But yeah, it's always so lovely to hear from the Tails team. I think we set an extremely high bar on.
There, we had another question coming.
Did we? There we go. Okay, from Sebastian, do you use external tables in your project and those tested in CI?
By external tables, do you mean referenced from a bucket or external to the project, like fixed tables?
I'm not sure from this question. I'm almost going to rely on maybe Jeremy to throw a comment in the chat because external tables are a thing that, there we go, Sebastian said correct.
To which? So we have a set of tables which are, as I mentioned, kind of reference tables, which we know to be, so we have a set which are kind of referenced, known to be correct test data that we kind of do a comparison against. We don't refer to any S3 tables as part of our project. What's the problem case that you're trying to solve? Yeah, and how are they tested? I mean, if it's it depends what the external table's for. If it's a source, we have tests, whether it's a latency check or, add DBT tests everywhere.
Yeah, good advice. Good advice. Well, actually, I think your team's very conscious of where you add tests, which is an interesting approach from what I remember. I followed the Tails team closely. I think. That's been the kind of historical. I think we'll probably revisit it. We're going through a big kind of migration at the minute from to a kind of data mart world where I think we'll probably have far more frequent lower level kind of per table tests. So yeah, it's always subject to change, is what I'd say. Cool. Well, I guess with that, we're going to wrap up. But thank you so much to the whole Tails team. I know it's not just Niall that has done this work, but a full team effort to sort of build your project in a way that provides such a great example from the community for the community. I know for ourselves, we've pinched some of your ideas around blue-green deploy. We're looking forward to implementing SQL Fluff. We're really excited that you were able to use this feature to your team's benefit so soon after its release, and really grateful for having you join and tell us all about it today.
Well, thank you for hosting.